Hey everybody, this is Games Plus James, and today we're going to take a look at how to add ScreenShake into your games. ScreenShake is a really powerful effect that can really help how your game feels and make it feel like you're having a greater interaction in the world. Now I've got a simple project set up and you can download the files for this down below if you want to follow along exactly, or you can just apply the same ideas to your own project you're working on. But I've got this very simple guy who can run around, I can shoot a wall, you can see we've got sound effects and it feels okay to shoot the wall. I can run over here and shoot this enemy. And it feels okay, but there's no real impact, it feels like, to when your bullets interact with the world. And what can really help that is adding some ScreenShake. So we're going to add a simple way to do that. So I'm going to stop this running here. And the first thing I'm going to do is create a script in my scripts folder that we're going to call ScreenShake Controller. And I'm going to add this to my camera. Like so. There we go. So obviously our camera is the main thing that we see in the world, and while you could potentially shake the whole world if you wanted to, it's much more simple to just shake the camera around when it moves. Now I've got a very simple camera setup. If I go to my camera controller here, all the camera is doing is following the position of the player in the world. So what we're going to do is, after the camera moves in the update section, we're going to go to the function that's called the late update, which occurs every single frame, but occurs after the update is called. And then we can move the camera in that frame. And that allows us to be able to control, hey, the camera will still go to the player's position in the normal update loop, but we can offset that a little bit to create a shake effect. So let's go back in here. We have our ScreenShake applied, so I'm going to double click this and open it up. And we're going to need a few variables up here. So we're going to create a private float, and we're going to create one for shake time remaining, and this is going to be how long we want our shake to last for. And we're going to create a float for shake power, and that's how powerful we want our shake to be on the screen. Now why are we making these private? Well, we want to make these private because these are variables that we want to set through code. We're going to create a function that will make our shake start to happen. So let's start off by creating that function. So I'm going to create a public void start shake, like so. And then in this function, we're going to take in two parameters. We're going to take in a float for length, and that'll be how long our shake lasts for, and we're going to take in a float for power. And then we're simply going to, no, that moved down there. We're simply then going to say, when this function is called, we'll say our shake time remaining will be equal to whatever length we set, and our shake power will be equal to the power that we send in. So obviously at the moment that's not doing anything, but we're just going to add into our update loop just for us to be able to test this out. I'm going to just add an extra button press. So if input dot get key down, let's say key code, let's go with K, a letter that isn't commonly used for actually playing the game. And we're going to say we're going to start a new shake, and we're going to give it a length of half a second and a power of 1. Okay, so that's all fine and dandy, but how's this actually going to do anything? At the moment, obviously, if we go back in here, we could see, hopefully, if everything works correctly, if I switch this to debug mode, and we go down and look at our ScreenShake, if I press play, I'm going to actually mute the audio for now, and we'll turn off maximize on play. Okay, so if I hit K, we're still paused, of course. If I hit K, you should see, there we go. Our shake time remaining is 0.5 and our shake power is 1. So let's make that actually do something then. So as I said, we're going to we're going to use the void late update function. And what we're going to do is, first of all, check, do we have any shake time remaining? So if our shake time remaining is greater than 0, well, that means, hey, we want to be doing a shake at the moment, and then we'll make that shake time count down. So shake time remaining minus equals time.delta time. Then we need to decide how much do we want our screen to move around. Now, obviously, we want it to move in a very random way. We don't want it to just shake side to side. We want it to shake up and down and all over the place. So we're going to pick two random amounts for the x value and the y value. So we'll create float x amount will be equal to a random dot range, well, not random range, random dot range between -1 and 1. So we'll randomly pick a number between -1 and 1. And then what we're going to do with that is multiply that by whatever our shake power is. So however much shake power we're wanting to create, we're going to do it in here. So basically we're saying, hey, if you pass in a power of 5 in here, then you'll get it multiplying by -1 or 1. So it'll be somewhere between -5 and 5. So we're going to multiply this here by the shake power, like so. Then we're going to do the same for the y-axis. So float y amount equals random dot range between -1 and 1, again multiplied by the shake power. Okay, so that's the amount we wanted to move. So we then need to apply that to our camera to make it move around. So transform dot position, we can say plus equals, because we're going to add on a new value to our camera's current position. So we'll say plus equals a new vector tree, and we're going to move on the x-axis the x amount. So we're going to say x amount. On the y-axis we want to move y amount, and then on the z-axis we do not want it to move at all, so we're going to say 0. Okay, and that's pretty much it. That's the basics of what we want to do here. We can save this, we can go back then into Unity, and once that compiles, I'm going to turn this off debug mode because we don't need to see that anymore, but I can hit play, and now when I hit K, boom, we get a nice big explosion shaking the whole screen. And that's great, that works perfectly fine, but let's see if we put in some more values just to see what happens. If I make this tree, and we'll make it last for 1 second, go back in, press play, and we get this huge shake all over the place. Now, what's really weird in terms of how real physics works and things like that is we're getting a constant huge shake for that 1 second, and then it instantly snaps back to no shake. So what we would really prefer to happen is that when you start a shake, it's really big, but then gradually it gets smaller and smaller and disappears. So let's set that up. So let's stop this running here, go back into our script. I'm going to put this back to being 0.5 because the tree is a little bit ridiculous. So we're going to keep that back at the original values we had, and we're going to add in another variable up the top up here, and we're going to call this the shake fade time. And this is going to be how fast we want our shake to kind of fade out. And we want to set this down in here when every time we start a shake, we want to set this shake fade time. So we're going to say shake fade time. And what we're going to set it to be is equal to the power that we have, because we want the power to decrease. So we obviously, if we have a power of 2, we want to say, hey, we're going to start decreasing at 2. At the size of 2. Now, if that was happening over 1 second, basically what it would be doing is saying, hey, that would be reducing by 2 every 1 second. But what if our shake is less than 1 second? As we have up here, we have it set to be 0.5. So if our shake is less than 1 second, it would only reduce it by half the value, because it's only supposed to last for half a second. So we'd end up with the shake being big at the start, going down to halfway, and then immediately stopping. So we don't want that. So we want to make sure that we set the fade time to be the power divided by the length. So now the time it takes will be decreased completely. So let's then apply this to our shaking that we have going on. And up here, we're going to say our shake power. So the power that we're using to multiply how much we're shaking, we're going to make that decrease. So we're going to set it to be equal to matf.move towards. We're going to say, we'll start off with whatever our current shake power is. We're going to move towards 0 because we want it to get weaker as it goes. And then how fast we wanted to do that is the shake fade time multiplied by time dot delta time. Nice and simple. So let's see this in action. If I save this and I go back in here, let that compile, and when I press play, when I hit my shake, you can see it gradually fades down. So it starts as a big massive shake, but fades away as it goes. And again, let's try exaggerate those values to see how it looks. So I'm going to set this to 1, and we'll set it to 3 power. And if I play, you can see it gradually fades down. So it's no longer just a big massive shake that continually shakes forever. We get a nice kind of smooth gradual process. And that, just as an example to see what's going on, if we go to debug over here, and if you keep your eye on the power and the fade time down here, when I hit K, sorry, not the fade time, the power and time remaining, you can see as the time remaining counts down, the shake power counts down to 0 as well. You can see it counts down perfectly. Now, as an example of just what I was talking about in our script a moment ago, if we don't divide it by the length here, and if I put this back to 0.5, 0.5 there, if you keep an eye on the shake power this time, when I hit K, you can see it actually counts down to roughly halfway because it didn't get to complete its full shake. So you can see with our shake on the screen, it kind of just abruptly stops, much like we had before. So that really, really doesn't feel nice to a player. So that's why we need to make sure we divide it by the length. Okay, so that shake fade is working perfectly, but one extra thing we can do to make it feel a little bit more vibrant and interesting for a shake is not just to shake it around from side to side, but also to shake the rotation of the camera. By adding a little rotation to the camera, it actually makes it feel even more impactful and much more interesting for the players. And sometimes it's actually more interesting to do a rotation and not move the camera around. Sometimes you can achieve the same effect with just a little bit of rotation. But we're going to stick with using both. So we need one final float. We'll need a couple of final floats, but we're going to have one final private float that we're going to call shake rotation. And we're going to add an extra public float that we're going to call rotation multiplier. And the reason we do this is because obviously a rotation goes around 360 degrees. So sometimes to get a big rotation on the screen, you need to multiply it. You need to multiply out the power value that we're putting in for our shake. So let's go down to the bottom here. And we're going to say in our start shake function, our shake rotation equals our power multiplied by our rotation multiplier. So when we say we set our rotation multiplier by default to be equal to, we're going to set it to 15. So then what will happen when we call this one is it'll get 15 multiplied by 3 is 45, and it'll say, okay, the power of this now, the shake rotation is 45. So then what do we do? Well, we need to go up here into our update function, and we're going to say, we're going to do the same as we did for our shake power. We're going to make this rotation fade out over time because we want it to also disappear nicely as it goes. So we're going to say shake rotation equals matf.move towards the shake rotation. So first of all, we're going to move it towards 0. And how fast do we want it to go? Well, we're going to stick with the same shake fade time as we had before, which is the power divided by length. But because we multiplied our shake rotation by the rotation multiplier, we also need to multiply our shake fade time here by the rotation multiplier, and then finally multiply it by time.delta time. So that'll make that go down to 0 at the exact same rate as the shake power is going down. So how do we actually apply our rotation? Well, we're going to apply it outside of our late update. And the reason we do this is because obviously when we get our shake rotation back to 0, we want it to stay at 0. We don't want our camera ending up with a slight rotation either way. So that's really no use to us. So what we'll do is outside of our shake time remaining, we're always going to be making sure that our transform dot rotation is being set to a quaternion dot Euler. So quaternion dot Euler is how we can convert a vector tree into the 4 numbered quaternion entity. Quaternions are complicated, and if you don't understand them, that's okay. They're very, very weird, but we can very simply make them just a vector tree by doing this. So then we need to give it 3 different numbers, an x, y, and z value. And obviously, how do we know which one we want to change? Well, if we go back in here and go to our camera, once that compiles, go back up to the top up here, and on our rotation, if we rotate the x-axis, oh wait, no, that's not doing anything. There we go. If we rotate the x-axis, you can see, well, that's not doing what we want there. That's kind of rotating our whole world around. That's not really great, or it's moving things vertically. On our y, well, that'll start squashing everything down, and again, that's not really great. But instead, on the z-axis, you can see this is giving us this nice rocking motion. So we know we want to change the z-axis. So let's go back in here, and we're going to say, okay, well, on the x-axis, we'll do 0. On the y-axis, we'll do 0. And then on the z-axis, we'll do the shake rotation. I'm going to multiply that by a random dot range between -1 and 1. So again, we're giving a little bit of randomness to this shake. And that's it. Let's save this. We'll go back in to our game. Let that compile. You can see now we have our rotation multiplier up there. So now if I go in here, if I hit my button, you can see, oh, we get a big massive shake now. Suddenly the shake feels much more alive and powerful. Just an example of just the rotation itself working. Let's just take out the bit of code that moves the position of the camera. Let that compile again. And you can see, oh, we got a big massive shake. I might actually pull this down a little bit. 15 might be a bit too much. Let's go halfway, see how that feels. There we go. That feels a little bit better for the amount of shake that we want in that moment. So again, let's pull this back down to 7.5. Now, oh, actually, before we go any further, let's make sure we pull this back in here too. And I'm going to put this back to 1, just so we can see how that kind of rotation works on our screen. Let that compile, play, and there we go. Okay, so we're getting a nice bit of shake around, a little bit of rotation too. And this is all fine and great, but obviously you're not just going to be sitting in your game pressing the K button on your keyboard to make things shake. We want to actually make this have an impact in our game. So to do that, we're going to make it so that we can call this function from anywhere, so that objects don't have to search for the ScreenShake controller and then do it or anything like that. So we're going to make it a singleton by making a public static ScreenShake controller. So we're making a version of the script itself, and we're calling it instance. And then in the start function here, I'm going to say instance equals this. So as soon as the game runs, it'll go, okay, set the instance, which is a copy of the script itself, as this copy of the script. So that'll be the one that's attached to the camera. And when we make it static, that means it's the same for all versions of any ScreenShake controller in the game. And the way we can then access that is by just accessing the instance that is attached to any version of this script. It's very, very simple, very, very straightforward, but really, really powerful. So what that allows us to do is, for example, to go to, I'm going to go to my, let's go back in here. No, actually, yeah, we'll go to the bullet controller here. And this is when the bullet impacts with a wall. So as soon as it impacts with the wall, it creates a little effect and then it destroys itself. So just before it destroys itself, I'm going to say, go to the ScreenShake controller, .instance, and then call the function start shake. And then how much shake do we want to give it? I'm going to say, we'll make it last for 0.2 of a second and have 0.1 power, because it's only a small bullet impacting a wall, so we don't want that to be overly powerful. So let's see that in action. So we save that, and if I go back into my script, you can see if I go look at my prefabs here, where we have our bullet, that has the bullet controller. Where are we? There we go. The bullet controller script is attached just here. Very simple. And then I can go ahead and play. And now, when I hit the wall, there we go. We get a nice little impact effect. And suddenly, our world feels a bit more real and realistic. But if I go up here and shoot this guy, we're still only getting that small little vibration when it hits that guy. And he does a big, massive explosion. So let's go and add a little function to where that enemy is being destroyed. So again, I'll go back to my scripts, and in here I've got an enemy script, and again we have him instantiating a death effect and then destroying himself when he gets hit by a bullet. So here I'm going to say ScreenShake controller. Oh no, that's the wrong one. ScreenShake controller dot instance dot start shake, and this one we're going to make a bit more exaggerated than just that little simple bullet impact. We're going to say 1 and 1, I think is okay. So then we can save that and go back in here, and if I press play, and let's maximize it this time. So I go over here and shoot, you can see, there we go, there's our nice little simple impact. But if I go over and shoot this guy now, oh, we get a big massive explosion, and suddenly it feels much more impactful in your game. And in fact, let's stop this and run again. This time I'm going to do it with the audio playing, so now you'll get an even better feel of, you've got visual feedback from the impact animation of the sprite. We've got even more visual impact with the shaking of the camera, and then we've also got sound backing it up to make everything feel like a complete and solid impact in the world. So you can see already that feels pretty nice. And then if we go over here and shoot this guy, that really felt like a big meaty explosion. And ScreenShake is really easy and simple to do. It's, as you can see, it's only a few lines of code, but it has a huge effect on your game and really helps make the game feel like it plays a lot better. So there you go. Thanks for watching this episode. If you enjoyed what you saw, make sure you hit that subscribe button, like this video to help more people learn how ScreenShake can help their games, and I will be back soon with more game dev tutorial goodness.